number 14. Not ready for that yet. Not ready for that yet. Maybe I went the wrong way. It's only a one-part problem. Still only one, so I didn't go far enough. It should have been 14. Let's go to 15. Still not the problem I want to look at yet. Still not the problem I want to look at yet. There we go. So it's going to be kind of later in the exercise before you start seeing two-part graphs that you actually have to graph. Now notice, again, the vast majority of the problems that you get, the coefficients on x and y are going to divide the constant value. You will get whole numbers. Won't say all of them, but I will say the vast majority of them are up there. So this should be almost one that we could do without a lot of technical work. So if x is equal to 0 in the top equation, then y does all the work, so y has to take on a value of. If x is 0, then you've got to divide by -4, so y has to be -2. And if y is 0, then x has to be all -8. In the bottom equation, if x is 0, then y loses its emphasis. Excuse me, if x is 0, y loses its emphasis, or x loses its emphasis, and y has to be a value of 6. And if y is equal to 0, then x has to be a value of 2. So those are the points that I'm going to graph. Click to enlarge, slide this out of the way so I can see the points of the problem. First line has to go through 0 and 2. That took me less than 2 seconds to do. And also has to hit -8 and 0. Second line, yeah, you got to come back to the line tool again. Goes through 0 and 6. And also has to hit 2 and 0. And both of those are solid lines or dotted lines? Solid, because they use greater than or less than or equal to. So now I have 4 regions to worry about. It's either going to be here, 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 or here. Any ideas? Then pick one and start working. Let's pick one that sits out here somewhere. Let's pick a point in that region somewhere. That's your decision. I'm not making it for you.
6, 4.
6 and 4. 6, 4 gets a little bit tight, but as long as you can see it's clearly in the region, you're okay. So we've got 6 and 4. So let's see. 6 minus 4 times 4 is greater than or equal to a -8. 6 minus 16 gives me a -10. Is -10 greater than or equal to a -8? No, it's not. I'm better off if I'm $8 overdrawn than I am if I'm $10 overdrawn. Neither one of them is a good overdraw, but being -8 is better than -10. Okay, so it didn't satisfy the first equation. If it didn't satisfy the first equation, would you even waste any time checking in the second equation? So a negative vote is actually a benefit because it saves you some work in the problem. But we found out that this isn't the right region. So let's try another one. Where next?
4.
4, 0? Okay, so 4, 0 is down here. So now 4 minus 4 times 0 is greater than or equal to a -8. Is 4 greater than or equal to a -8?
No.
That's true, isn't it?
Yeah.
Okay. Then 3 times 4 plus 0 is less than or equal to 6. Is 12 less than or equal to 6?
Yeah.
No.
Oh, no,
Okay? I'll give you time to change your mind. Okay, so that's not the right region, so this is a big no region as well. See, there is some trial and error to this, but it's not wild guessing. You gotta figure out which region it's in, and there's the only safe way to do it all the time is a point test. And I know I'm doing it by hand in here, but I'm surprised that someone said, well, can't we do this on the calculator? In which case I would say, hell yes, why not? Why should you do the ugly work? I mean, 'cause I actually saw some people pick up their calculator. I don't pick up a calculator very often because I don't need one except when it gets to be big numbers or small numbers. Sometimes any number. Okay? So I'm 0 for 2 so far.
-2, 4.
-2, 4. -2, +4 would put it up here. So -2 minus 4 times a +4 greater than or equal to a -8. -2 minus 16, -18 greater than or equal to a -8 is a no. That's not true. So guess what? Process of elimination, you weren't good at guessing which was the right region, but does it eventually narrow itself down? So for graphing standpoint, that's the region that should be shaded? Okay, so I clean up this garbage out here so it doesn't show up anymore. I save it back to the home screen. I check the answer. That's all they wanted me to do. Giving more equations in the graph isn't going to change anything. It just makes more work for the problem, and it makes your ability to be able to find the feasible region a little bit more challenged.